Hello everyone, welcome back to my channel, and we're going to continue our series on TryHackMe's web app pen testing. And today's topic is going to be file inclusion path traversal. There two are connected in some ways, and it's beneficial for us to actually cover these two vulnerabilities at the same time because they have some similarities and similar techniques to exploit. So what is the vulnerabilities? File inclusion and path traversal are vulnerabilities that arise when applications allow external input to change path for accessing files. Imagine a library where the catalog is manipulated to access restricted books. Similarly, in web applications, vulnerabilities arise from improper handling of the file paths and URLs. These vulnerabilities allow attackers to include files not intended to be part of the web application, leading to unauthorized access or execution of code. Objectives: understand what file inclusion and path traversal attacks are and their impact. Identify file inclusion and path traversal vulnerabilities in web applications. Exploit these vulnerabilities in a controlled environment. Understand and apply measures to mitigate and prevent these vulnerabilities. Prerequisite for the room is basic understanding of web application architectures and server-side scripting, basic knowledge of OWASP ZAP Burp Suite, vulnerabilities, and familiarity with programming languages like PHP or Python. We're going to deploy our target machine as well as the attack machine. The structure of a web application are a complex system comprising several components working together to deliver a seamless user experience. At its core, a web application has two main parts, the front end and the back end. The front end is the user interface of the application, typically built using frameworks like React, Angular, or Vue.js. It communicates with the backend via API. The server-side component processes user requests, interacts with databases, and serves data to the front end. It's often developed using languages like PHP, Python, and JavaScript, and frameworks like Node.js, Django, or Laravel. One of the fundamental aspects of web applications is the client-server model. In this model, the client, usually a web browser, sends a request to the server hosting the web application. The backend server processes this request, and the client and server communication usually happens over the HTTP or HTTPS protocols. So if you take a look at this diagram, let's say that you, as a TryHackMe user, you try to send a request to login on the front end. When you click the login button, you enter the username and password. The front end, which is the browser, will forward your request with your credentials to the backend server. The backend server of TryHackMe is going to interact with database and some other configuration files. First, validate your authentication, and then secondly, if you're authenticated, then it's going to fetch whatever resources that you have access to. In general, some file system, and then once it gets a response, it will send the response back to the front end, which is the browsers. The browser will process these responses and display it to us, which is our user. If we log into TryHackMe, we present it with our dashboard. That's the client-server model. Server-side scripting and file handling. Server-side scripts run on the server and generate the content for the front end, which is then sent to the client. Unlike client-side scripts like JavaScript in the browser, server-side scripts access the server's file system and databases. File handling is a significant part of the server-side scripting. Web applications often need to read, form, or write files on the server. For example, reading configuration files, saving user uploads, or including code from other files. The application below includes a file based on user input. If this input is not correctly validated and sanitized, an attacker might exploit a vulnerable parameter to include malicious files or access sensitive files on the server. The attacker could view the server's password file. So if you take a look at this URL right here, the page that we requested is going to be the menu.php file, which is located in the var/www/html folder. Now, if you're familiar with Linux system, you know that something that interests attackers are the password file, which is located in the exit folder. So instead of fetching the PHP file, if this web application is vulnerable, then attackers can actually request the file from the SC folder, which is the password file right here. As a result, the content of the file will be displayed on the web application. So basically, that's the vulnerability that we're going to talk about. In short, file inclusion and path traversal vulnerabilities arise when user inputs are not properly sanitized or validated. Since attackers can inject malicious payloads to log files in this folder and manipulate file paths to execute the logged payload, an attacker can achieve remote code execution. An attacker will also read configuration files that contain sensitive information, like database credentials, if the application returns the file in a plain text. Lastly, insufficient error handling may also reveal system paths or file structures, providing clues to attackers about potential targets for inclusion attacks. All right, let's talk about inclusion types. Basics of file inclusion. A traversal string, commonly seen as ... is used in path traversal attacks to navigate through the directory structure. Is a way to move up one directory level. Traversal strings are used to access files outside the directory. Relative pathing refers to locating files based on the current directory. For example, include folder file. Absolute pathing involves specifying the complete path starting from the root directory. Remote file inclusion. Remote file inclusion, or RFI, is a vulnerability that allows attackers to include remote files through input manipulation. This can lead to execution of malicious scripts or code on the server. Typically, RFI occurs in applications that dynamically include external files or scripts. Attackers can manipulate parameters to external malicious files. For example, if a web application uses a URL in a parameter which points to an external website, an attacker can replace the URL with a path to a malicious script. Local file inclusion, or LFI, typically occurs when attackers exploit vulnerable input fields to access or execute files on the server. Attackers usually exploit poorly sanitized input fields to manipulate files, aiming to access files outside the intended directory. For example, using a string, an attacker will access sensitive files. Here, we go up several folders levels to access the SC folder, which will give us access to the password file. While LFI primarily leads to unauthorized file access, it can escalate to RC, which is remote code execution. This if attacker can upload or inject executable code into a file later included or executed by the server. Techniques such as log poisoning, injecting code into log files, and then including those log files are examples of how LFI can lead to RCE. This is the diagram showing the RFI versus LFI process. This is the RFI exploitation process. Attackers will exploit the vulnerable web application, which fetch an external file from the external server. This external file may be malicious script that can be run on the server, and then once the application fetches this malicious script, it will execute the code, leading to remote code execution. LFI exploitation is different. Instead of fetching resources or malicious script from an external server, attackers actually try to access some internal file system. Most of the cases are going to be the logs file, and then attackers inject malicious code in some other file systems. And when these file systems are executed by server, the injected codes are also executed. So this diagram differentiates the process of exploring RFI and LFI vulnerabilities. In RFI, the focus on including an executed remote file, whereas in LFI, attacker aims to access local files and potentially leverage the access to execute code on the server. It refers to locating files based on the current directory. That's relative. What kind of pathing involves the file's complete path, which usually starts from the root directory, is absolute pathing. PHP Wrappers are product functionality that allows users to access various data streams. Wrappers can also access or execute code through built-in PHP protocols, which may lead to significant security risks if not properly handled. An application to LFI might include files based on user input without sufficient validation. Attackers can use PHP Wrappers filters. These filters allow a user to perform basic modifications operations on the data before it's written or read. If an attacker wants to encode the contents of a file, like the password file, in base64, this can be achieved using the convert not base64 encode conversion filter. The file will be PHP filter and specify the resource to encode. For example, go to this URL and use the final payload above. Once the application processes this, the server will return the password file, which the attacker can decode to reveal the contents. Usually I can copy and paste, but the most important thing in learning is to type, memorize it, record it, and then try to read. That's how we remember commands and the wrappers, everything. So it's going to be PHP filter convert basis for resource. Let's see. P convert the base for source equals see dot pass filter convert basis for encode resource and see dot password. Should be correct. Let's run it. And we got a basis for string. Now we go to server share. We got the content of the password file right here. Yep, that's what it is. There are many categories of filters in PHP. String filters, string rotation to upper to lower switches, conversion filters, convert from basis forward to basis for encode or decode, convert coded printable decode. So these are some filters now we have in, or some compression filters, zip, deflat, or inflate, encryptions. So for example, the table below represents output or target files .hc access using different string filters. So basis for encode is going to be having some output like this. If we have string filters, it's going to look like this, and to upper, to lower. All right, so basically that's it. Let's try it. To upper, PHP is that encoding, try string to upper. Everything is converted into uppercase. It doesn't matter. Let's see this option. What does it display? Nothing really. Not sure what it does, but let's skip it for now. It's not really important. Data wrapper. The data stream wrapper is another example of PHP wrapper functionality. The data wrappers allow inline data embedding. It is used to embed small amount of data directly into the application code. So if we go to the same URL and use the payload data text length, this one is going in the image below. The URL could cause a PHP code execution, displaying a PHP configuration details. The breakdown of the payload data is served as a URL. The MIME tab sends text, the plain text, and the close is PHP code snippet, PHP info, which will display the whole PHP versions and information of the system. So this is a PHP code, right? Okay, understand. What part of PHP functionalities allows user to access to various data streams that can also access or execute code through built-in data wrapper. PHP wrapper. In web applications, safeguards are put in place to prevent path traversal attacks. However, these defenses are not always foolproof. Below is a code application that insists that the file name provided by the user must begin with a predetermined base directory. So this is the code. It's possible to comply with the requirement and navigate to other directories. This can be achieved by appending the necessary directory traversal sequences. After, go to this URL and use the payload var HTML, and then we just go back. We can actually get to the password file. The PHP function contains string, checks if a substring exists within the string. The if condition checks two things. First, if the get page does not contain any substring, and if the get page contains the substring of this. However, this bypasses the filter because it navigates up to two directories. Similar to this one, it does not exactly match the block patterns due to the extra slashes. The extra slashes in this are treated as a single slash by the file system. This string and this string are functionally equivalent in terms of directory navigation, but only this one explicitly filters the source code. What does it mean? Let's slow down. Let's go to this one. We try the payload and we get the contents. What happens in Linux? Let's say we're in Postman folder, right? And want to access the SC folder. We can SC from this folder. We have to go up one folder, which is now we at root. Now we have go up one more. Okay, we have the root folder we were in, and we're interested in, right? So now I was in Postman folder, and I want to access the password file in this folder. I use cd slash. Now I'm in root. I go up one directory, which is root, and then up one more directory, which is the system root. Okay, and from here, I'm going to SC folder. So now SC folder, which I can view the file password. Right. The same thing with the double slash. So let's go back to Postman folder. Let's say I want to go to the SC folder. Do the same cd double dot. Then instead of a single slash, we can use double slash. So now we're in the root folder. One more to the system root folder, and then now we're at SC folder, and we use double slash. No, here, that's fine. We still land on the same folder, which is SC folder right here, SC folder. So let's say we want to view the password file. We can just cat the content. The if condition checks two things. If the get page does not contain the substring slash dot, and if the get page contains the substring var www.html. However, slash bypasses this filter because it still navigates up two directories similar to slash. It does not exactly match the block patterns due to the extra slashes. The extra slashes in this substrate are treated as a single slash in the file system. This means that these two substrings are functionally equivalent in terms of directory navigation, but only this one is explicitly filtered out by the code. So the content string is right here, function right here. As the paragraph explained, it checks for two things. If the page contains the string and it contains the base directory folder. The application payload is correct. Now that we're trying to view the password file, we are not permitted because the application has blocked us from accessing this file. Why? Because when it checks for the URL, it contains the substring ///. But if we have extra slash, it's going to be a different story. It displays us the content of the password file. So what happens? What it means is that, so right now we're in Postman folder, right? And if we want to view the content of the password file, we can use the same directory. So cd var html. So now we're in current directory. This is the base directory of the application. Usually to rebuild the content of the password file, it's going to be a command path html and then /2 sc. Usually this is what we would do. But because the application blocks the substring ///, we can't even use this payload anymore. To bypass this, add extra slashes. So we did the same thing. Cat www html, and then over here we have // sc password, and it should function the same. Instead of using // we can bypass the application's defense mechanism by using // I know it's a bit confusing when I keep saying that, but moving on, techniques used to bypass basic security filters. Applications have these filters typically look for obvious directory traversal sequences like //. However, attackers can often evade detection by obfuscating these sequences and still navigating through the file system. Encoding transforms characters into different formats. In LFI, attackers use URL encoding, the percent encoding, where characters are represented using percentage symbols followed by hexadecimal values. For instance, This will be encoded or obfuscated in several ways to bypass simple filters. Encoding twice. This becomes this. Attackers can use the payloads like ... double slashes, which help to avoid detection by simple string matching or filtering mechanisms. This obfuscation technique is intended to conceal directory traversal attempts, making them less apparent to basic security features. For example, imagine an application that mitigates LFI filter output ... An attacker can potentially bypass this filter using the following methods. Encode bypass. The attacker can use a URL encode version of the payload. Like this, the server decodes this input to the config PHP file bypassing filter. Or double encoded bypass. Attackers can use double encoded identification decodes input twice. So the payload becomes something like this part. Let's take a look at what it means. Obfuscation. An attacker could use a payload like this, which after the application stripped out the apparent traversal string, would effectively becomes this. Alright, so let's see what it means. Usually URL encoded bypass. What it means is that, let's say you have a page, we have a file like this, encoded. So the application is filtering this. So this is the defense mechanism that the application implemented to prevent path traversal. So if the payload is not encoded, if it's something like this, the application will recognize, this is the filtered string that we match in the system, in the code, block this one. It will never work. One way to bypass this is URL encoded. Now the payload becomes something like this. The %2e is the dot size. Attackers manually do it like this. Obfuscation techniques are often used to bypass security filters that web applications might have in place. These filters typically look for obvious directory traversal sequences like ... However, attackers can often evade detection by casing these sequences and navigate through the server's file system. Encoding transforms characters into different formats. In LFI, attackers use percent encoding, where characters are represented using percentage symbols followed by hexadecimal values. For instance, ... can be encoded or obfuscated in several ways to by standard URL encoding. If we have ... is something like this. It doesn't matter for upper or lower case, it's still representing the same values. Double encoding, useful if the application encoded input twice. So this becomes this. Let's try it. We URL encode the string twice. Obfuscation. Attackers can use a payload like ... which help avoiding detection by simple string matching or filtering mechanisms. This obfuscation technique is intended to conceal directory traversal attempts, making them less apparent to basic security filters. This obfuscation technique is intended to conceal directory traversal attempts, making them less apparent to basic security filters. For example, imagine an application mitigates LFI by filtering the ... right? And there are three simple ways to bypass these defense mechanisms. First, we URL encode the string, like we mentioned earlier. So ... config.php will becomes %2e, %2e, %2f, config.php. We can also URL encode the string, which then become this string right here. Notice that this is not encoded, which is fine in this case, but sometimes you may encode this period or this dot right here. All right, and attacker could use the payload ... config.php, which means that application strip out the apparent traversal string effectively becomes, as you see the code, if it sees something in this string like ... it will strip out. So when it encounters something like this, let's see, I see this, so I'm gonna remove these strings. So now this original payload becomes, because these three characters have been removed, now the original payload becomes by directory. That's how you bypass the basic defense mechanisms web application filtering. Moving on from LFI to remote code execution. Section files. PHP section files can also be used in LFI attack, leading to remote code execution, particularly if an attacker can manipulate the section data. In a typical web application, section data is stored in files on the server. If an attacker can inject malicious code into these section files, and if the application includes the files through an LFI vulnerability, this can lead to code execution. For example, the vulnerable application hosted on this URL contains the code below. An attacker could exploit this vulnerability by injecting a PHP code into the section variable using echo PHP info in the page parameter. This code is then saved to the section file on the server. Subsequently, the attacker can use the LFI vulnerability to include the section file. Since IDs are hashed, the ID can be found in the cookie section in the browsers. Once we get the cookie values, accessing the URL sections.php page, the section ID, which records your sections, can be found in the PHP sections folder where the file is specified by the section IDs, which is your PHP section cookies. Because this web page is vulnerable to LFI, we can actually see the content of the section file and access the section file on the target system. That's how you can leverage LFI for remote code execution, log poisoning. Another type of remote code execution is to poison the log. Log poisoning is a technique where an attacker injects executable code into the web server's log file, then uses an LFI vulnerability to include and execute this log file. This method is particularly stealthy because files are shared and are similarly harmless applications operations. In a log poisoning attack, the attacker must first inject malicious PHP code into a log file. This can be done in various ways, such as crafting an evil user agent, sending a payload via URL using net, or a referral header that the server. Once PHP code is in the log file, the attacker can exploit an LFI vulnerability to include it as a standard PHP file. This causes the server to execute malicious code contained in the log file, leading to RCE. For example, if an attacker requested a vulnerable machine containing the code, something like this, let's see, the code will then be into the server access log. The attacker is include the access log file. So it's a little bit confusing. Let's try to see what that means. First, try netcat. This is the target application, the target IP address, and the port number is 80 because it doesn't use send a netcat request to a vulnerable machine containing code. Just what is it? Okay, so let's try that. For example, if an attacker sends a netcat request to the vulnerable machine containing PHP code, right here, I don't know why it's not displaying this, the code part, but that's fine. So basically, we send a netcat request to the target machine on port 80 with PHP code. The response we get back is something like this. If we access the log file and the var log apache 2, we see something like this. Usually when you visit a website or an application, all your activities or requests will be recorded in the log file. You can see everything we did from the beginning, like from the playground.php, or we have, I think, LFI. It's going to be something. Yeah. We also trying some LFI.php file get request, and everything will be logged into this access log file. And because we were sending a netcat command on this port with this PHP code, at the end of this log file, you're going to see the PHP information, everything, the information of the system right here. We send a request with injected malicious code. When we access the log, it shows everything. The code is executed and we get information on the system. That's how we poison the log. So what technique does an attacker use to inject executable code into web server log and then use a file inclusion vulnerability to include and execute the malicious code? To sum up the log poisoning part right here, first, we know the application is using PHP and we know the locations of the access log. Every time we visit the application, our information will be into this access.log file. And because the application is vulnerable to LFI, we can access this log file. When we're sending a command to our target application with the PHP code execution, the PHP code right here, will also be into the access.file. But it's not executed yet until we access it. Once we view this file, the code that we sent will be executed. Hence, the content will be displayed right here. PHP wrappers can be used not only for reading files, but also for code execution. The key here is the PHP filter stream wrappers, which enables transformations of check the PHP basis for filter as an example. This method allows attackers to execute arbitrary code on the server using a basis for encoded payload. So if we go to this same URL playground, we use a code as our payload. The value of the payload when encoded to base64 will be PHP, something like this. And then here's the table to explain the protocol wrappers. Filter uses convert. The resource type is specified by the data plain text right here. And then here's a payload, the encoded payload, the base64. So basically what it does is, the payload does is, it will read the payload, which is the base64 encoded string, and decode it and then load it into the system. Okay, this is it. When the server processes this request, it first decode the base64 string and then execute the PHP code, allowing the attacker to read command on server by the command get parameter right here, the CMD right here. If you see the URL right here, CMD equals who am I, we should not include this second part into this input field right here. We should only include that after we input the payload into the URL field. Here's the payload we have. We can get our original payload right here, go to server share, and to base64, we're going to get same string, PHP filter, and then convert base64 decode, and then resource data length. We're gonna see an error because we didn't include the command. So here we include a command equals who am I? Something's wrong. This payload right now. Custom filters. We're going to get this one, and here we're going to use cmd equals who am I. Here we got it. So the question: what's the content of the hidden file in the flags folder? So first, let's see where this flag folder is. Whether it's in the HTML folder. Let's see ls, and yes, we have the flags folder right here. Just want to make sure that is actually under var/www/html folder. And yes, this is our current directory, and the flags is under this HTML folder. Right, the next thing is the hidden text file name. We don't know it yet. So let's try ls. Yeah. This is the text file. Now that we know the name, we can request it. PHP filter convert base64 resource is var HTML flags, and here's the text file. Okay, we got a base64 encoded string, so we gotta be coded, and we're gonna flag right here. Conclusion: file inclusion and patch reversal vulnerabilities arise from improper handling of user input into the web applications. In file inclusion, attackers exploit the way web applications handles files, leading to local file inclusions or remote file inclusion. On the other hand, patch reversal involves navigating to the server's directory structure to access files outside of the intended directory. Both vulnerabilities can be used to access unauthorized data or system compromise. Some mitigations and prevention strategies: ensure that all user inputs are properly validated and sanitized. This is crucial to prevent attacks from manipulating file paths or including malicious files. Implement allow listing for file inclusion. Define which files can be included or accessed, and reject any request that does not match. Configure server settings to disallow remote file inclusion, and limit the ability of scripts to access the file system. For PHP, directives allow URL opens and allow URL include should be disabled if not needed. Performing regular code reviews and security audits to identify potential vulnerabilities with the help of automated tools Manual checks are also essentials. Ensure that everyone involved in the development process understands the importance of security. Regular training on secure coding practices can significantly reduce this vulnerability. In conclusion, file inclusion and path traversals pose significant risks to web applications. They can be mitigated by security best practices. Developers and administrators must be proactive in securing web applications, studying the latest security trends, and continually refining approaches to application security. All right, so that's it for the room today. Hopefully you enjoy all the activities that we have and gone through. If you have any question, please feel free to reach out to me. If you like my content, please subscribe. Thank you, and I'll see you next.